Okay, so now my presentation is about muscle contraction, and since we already know a little bit about the structure of a neuron and what its function is, we're going to move ahead and look at what happens once the impulse reaches the axon terminal. So as we know, the axon terminal is carrying all these vesicles that contain neurotransmitters. And once they get to the synaptic cleft, it releases those neurotransmitters, or ACH. And they kind of float around there. And there's also some sodium and potassium in different quantities. But what really binds to the nicotinic cholinergic receptors is the ACH. Those neurotransmitters bind into these receptors, which in turn open up, and that's really what triggers the action potential. And this action potential travels through the sarcolemma, and within the sarcolemma we'll find some T-tubules, and as you can see them right here, the ACH travels down, and right up against the T-tubule you'll find the sarcoplasmic reticulum, which is where the calcium molecules are stored. And also we'll find the ryanodine receptors and the hydropyridine receptors, and I'm really having a hard time pronouncing them, so I'll just call it the DHPR receptor. And these are voltage gated channels. And what they do is, as the ACH is traveling down the T-tubule, they open up. And as they open up, they allow for calcium to flood into the cytoplasm, or the inside of the cells, through the calcium voltage gates. So once these receptors open up and they send a flood of the calcium into the cytoplasm, like I said before, this calcium binds into the troponin, which is also attached to the actin or thin filaments. But before we get to that, I want to say that all of this happens in the sarcomere, and a sarcomere is really a segment of the myofiber, which is really like the if you were to open up a tissue of the muscle, it's really the smallest unit of the tissue. So all of this is happening in the sarcomere, which is right here. And a sarcomere, it's really the distance between Z line and Z line, and this is looking inside the myofibril. And so in this section is where the contracting begins between the Z lines, and that's really what's causing the muscle contraction. And the thin filaments, or the actin, they're stored in the I band. So once again, the muscle contraction happens between the Z line and Z line in the sarcomere. And when these two lines come together is when the muscle contracts, starting the sliding filament theory. So, as I was saying, the calcium molecules bind to the troponin, which is in turn attached to the tropomyosin. And when the calcium attaches to the troponin, it causes, or the tropomyosin, it causes a shift change. And when this happens, it exposes the binding sites of the actin, or the thin filaments. And when that happens, the myosin, which is the thick filament inside the sarcomere, those heads that shift allows for the myosin heads, which are really contained with molecules of ADP and phosphate. And those molecules will then attach to the actin filament, and this is really what is doing that contraction of the muscle. So in other words, there's the actin filament and there's a myosin filament, and when the calcium attaches, then it changes shape and it creates like a sliding motion, exposing the actin side so that the myosin heads then attach to the thin filaments, and it creates this friction. So now, once all of this happens, and the ADP and the PI in the myosin head has created this force, then there's no longer any need, or it has released all of that energy, which again causes it to change shape, converting it into ATP. That's when all the energy has been spent. And once that happens, the whole cycle starts all over again, provided that there's enough force in the action potential. Now, there is a word that we need to come into play, and I really have a hard time saying it, so I'm going to have my telephone say it for me, and it is the acetylcholinesterase. Acetylcholinesterase. And what this is the conversion of the ACH, conversion and reabsorption of the ACH, or reuptake, so that this whole action potential can happen again. So the neurotransmitter ACH gets converted so that into acetylcholinesterase, so that it can be then taken back and be dropped back into the synaptic cleft, and this whole system start all over again. Thank you.